Hold on, I paused it. Shoot. All right, this is my test to determine if YouTube is lying to me or not, because very briefly, before I started live streaming, I was poking around this audio library, which browse and download free music for your project. Attribution not required. Of course, I don't mind using music where attribution is required. And I went to dark, and I went to classical, and I found Beethoven's Fifth Symphony. There's all sorts of other stuff I could try. Because I feel like I need something for the fourth dimension, because this is the Coding Train live episode where we will enter fourth dimension. No, maybe that's not what I meant. Let's try this one. Where we will enter the fourth dimension. Yes. All right. Anyway, let me get a move on here. I've got lots of time. But I got nowhere to be, nothing to do. So what you're seeing here, by the way, is what you're seeing here is a processing sketch that I made this morning. Let me correct the weird nonsense that I was playing with here. I was messing around with, it should be cosine, negative sine, sine, cosine, cosine, negative sine, cosine, negative sine, sine, cosine. Okay, so this should be, if I've done everything correctly, a spinning 3D cube with perspective, but the renderer is the P2D engine. And this is my last piece of Space Melon. It erases whatever is on my body, revealing what is behind it. It will provide me with the energy that I need. I also must, oh, this camera is off, erase this whiteboard. I'm going to draw some diagrams. And I'm just going to get started with this. I feel remarkably ready to tackle this problem, having done what I did this morning, as much of a disaster as that was. I think, I don't know. I don't know about this whiteboard eraser thingy that I've purchased from the internet. It is working a little bit better now. Okay. So just in case you didn't tune in this morning, I did about a 2-hour live stream programming this. And the idea for me was I wanted to learn how do on the most basic level, how do 3D engines work? How does it work to create the illusion of three-dimensional perspective on a two-dimensional surface? And the answer, it has to do with matrices. Projection matrices, rotation matrices, and there's much more to it than that. But I did the basics, and hopefully this will, and let me just move to the Slack channel here. Let me just see. Okay, let me move this out of the way. All right, no super important. Oh, I gotta, okay. Oh, wake up. Wake up. Well, this is really like, yeah, the free copyright music. There aren't a lot of choices. You have to pick like the most obvious, famous classical music piece. I'd love to do something more obscure, a little Mahler maybe. I don't know. It would be good for 4 dimensions. I also made it like much louder. Is it way too loud now? Oh, Tesseract is in the chat. From the 4th dimension to our dimension. Okay, I'm going to turn this back down. Okay, so let's do the following. I'm trying to think about this. I think we're going to start with this code. Do I dare start? I think I want to start from scratch is the thing. I mean, I definitely need this matrix. Oh, you know what though? This is why I probably shouldn't have, I'm going to have to add some code to this. Okay, yes, Simon, I have seen that video before. Thank you for posting it for me. I try to not have too many things in the chat here that have a, that open up a big thing, because I have the font very large so I can see it. And so okay, so let's see. I'm trying to think here. How do I want to do this? All right. I want to make a video where somebody could mostly program the Tesseract from scratch. So I think what I want to do is I'm going to end up redoing some of my code. So I am erasing all this. I'm going to end up rewriting a lot of this code, which now I feel silly, but I think I want to start over from scratch. And the Tesseract, okay. You know what? I'm going to leave some bits in here. Let me see. What bits can I leave in here? Okay. So I'm going to leave the points for a cube. I'm going to leave this angle variable. I'm going to leave the, I'm going to take this out. I'm in P3D now. Oh, P3D. And we'll leave this connect function. Okay, I think this should do the trick. Oh, and I need to do scale. Let's see. I'm just thinking here. I'll just do scale. Oh, I forgot the scale affects the stroke weight here. It's a little better. Oh, and this has to be Okay. And then, so this is annoying. So I'm not going to do it this way. I'm going to leave this. The noise never ends. You know, it's always so quiet in here when I'm not live streaming. And as soon as I start live streaming, there's always like right out in the hallway, just right outside the door, there's some construction, push some like furniture that has no wheels down the hallway, make a loud scratching noise. All right, so what I'm going to do is I'm going to say, and then I'm just going to use the scaled. Oh, this is so silly what I'm doing. Oh, this is so silly what I'm doing. I have a better idea. Camera goes off, of course. Jamie asks in the chat, why is processing chosen for today's video? Do most people not prefer to follow along in P5.js, or is that just me? You know, I kind of go back and forth. One of the reasons why I'm choosing to use processing right now is because I want to make use of its 3D rendering engine, and I'm just much more confident using the 3D rendering engine of processing than the WebGL rendering engine of P5, which is to say one is better than the other. It's just my own personal comfort level. Okay, so I made all these points. We're drawing stroke weight 16, points, connect them. Why do I not see my cube? Where's the cube, everybody? Oh, scale 100 is still in there. Okay. Oh, that was messing stuff up. All right, there we go. Now we can say rotate X by angle or something. Or rotate Y, maybe. All right. Alco writes, I can make a fake tesseract without using actual 4D math. Yeah, I was thinking of doing that. That's what I started doing, and then I was like jumping through so many hoops, and I felt like I wanted to learn and think about the fourth dimension in a way that I hadn't thought about before, and so that's why I'm going this route. But that is a very good point. All right, so I think we are going to get started. All right. I need a marker. All right. How's everyone feeling? This looks like this needs some triage. Okay. Okay. All right, I have to wake up. I was drinking a non-caffeinated beverage this morning, and then I just said, the heck with that. The thing is, I don't know if it reads, because I'm kind of tired. It's the end of the day. It's a Friday, but I'm so excited to do this. I hope that this becomes a video that is a good one. I could always just keep doing it over and over again. Oh, Marshall says, I'm so excited to get my coding train stickers. I did a whole, someone helped me with this today, but a whole mailing of stickers went out today. So if you signed up to be a member before August 1st, your stickers are actually in the mail right now to you. So be on the lookout for those. Again, I'm gonna keep saying this. Someone's gonna actually volunteer in the Slack channel. I would love someone to help me spruce up the membership stuff. So I want to add a whole bunch of emojis and icons, and I would thinking of maybe some additional rewards if that's of interest. But if you would love to volunteer to help with that, please let me know. You should try Expo wet erase markers. Yeah, that's what I got. That's what these are. I ordered them. Someone recommended these to me. These are Expo wet erase markers, I think. Right? Right? Isn't that what these are? I have another one. I got a pack of 2. I don't know where the second one went. Somebody tweeted this at me last week, and I ordered them instantly from a company that rhymes with Flamazon, because I have a Flime, that rhymes with Flime, membership. Oh, you know what's something else about Flamazon? I guess I can mention Flamazon now, because I was working on, I had like, I was kind of sitting somewhere where like I had to wait and there was nothing for me to do, which very rarely happens. And so I actually took a little time to work on Amazon.com/shop/coding-train, I think is the URL. I have one of these. No. Coding-train/shop, maybe? The Coding-train/shop? All right, I know how to get to it. If I go to YouTube, the Coding Train, and I click on, I'm going to get started coding soon, Amazon here. Yes, I don't know, Amazon.com/shop/the Coding Train. I started organizing things into categories here of like stuff that I use, and you can. I mean, this is really just a money-making thing. So hopefully this is like a helpful thing to you, because like you were looking for that book that I referenced. It's here, but this Amazon has set this kind of stuff up so that I can get a commission, which is helpful to me. I mean, I'm not going to turn it down, but really, I recommend you check out this nice list, because here's where you can get your own copy of A Million Random Digits or the same exact train whistle that I use. This is a unicorn floaty. I could not, I actually have one of these and I couldn't stay on it, so I don't know if I recommend it. This is a train hat. That's what I'd look for. But I have some other stuff in here too. And if you have ideas for things that you think I should include or things that I mention periodically, I would love to include them in here. All right, that's the Amazon shop. All right, so now, where am I? Oh, what happened to all my windows? Okay, wait, that's fine. Okay, this, I don't need the audio library right now. I'm not going to worry about this. I'm not going to worry about this. This is what I'm going to worry about, and this is also. Is there any way I can get this page to pop up? Let's go here. This is what I'll do. I want this page to pop up without playing the video and just the thumbnail, but I guess that's not a thing that YouTube does. Ooh. Wow, this is super helpful. Oh, look. All these people make these nice animations, and like, that's just not me. I'm gonna have to draw on the whiteboard. Okay. Include the space melon. Yeah, fill the cube for fun. Oh. Hello, Denmark. Random numbers. Guten Tag. Good evening, everybody. All right, so I think I'm ready to get going. Nobody can help me with this, huh? How can I make this show? I turned off autoplay. Speed, normal, annotations, quality. How? I want to show this page with the thumbnail. Nobody will help me because it must not be possible. My expectations are too high. I just think I can mention something and the chat will tell me how to do it as my own personal technical support. I need to be my own technical support. I need to learn new things, like visualizing a 4D tesseract. Okay, so that's fine. I'm just gonna I do what I said I was gonna do before, which is find a nice, there we go. A nice screenshot. There we go. Why? Oh, Bill asking, why is Fortnite recommended for you? Oh, I am in one of my alternative universe YouTube accounts that my children use. But what I'm trying to do by watching my educational videos in there is embed embed the recommendation engine with some new stuff for them to watch. Yeah, autoplay is autoplaying the next video. It's fine. It's fine. Everything's good, but let me log in as myself, which I'm always afraid to do. But I think this is going to be better. It really knows that I like tesseracts. Okay, so I'm going to move here. This is pretty good. Come on. Okay, that's good. That's good. Okay. Yes, that's the image. Correct. All right, that's a very good. Me-IM3 is making an interesting solution. I think I'm going to live with this being visible. Oh God, I can't resist. I can't resist that suggestion. Hold on, let me at least copy video URL to current time. I just can't resist this suggestion. Nope. All right, this is going to do just fine. Tesseract. Okay. And I have my code. So this is minimized. This is minimized. This is up and running. Then I have my code so far. Okay. Too many nines, indeed. All right, we're going to get started. I'm going to get started. Let me cycle the cameras. Okay. Here we go. Where's the train whistle? My lucky train whistle. Where did it go? Ah, there it is. Welcome to a coding challenge where I will enter the fourth dimension. Well, I didn't really time. I expected some dramatic moment to happen with the music there, which didn't happen. But all right, so this is a coding challenge. I'm so crazily excited about this. If this actually works, I think that I don't know what's going to happen. Stuff will just like smoke and brain matter will start just like leaking out of my nostrils. I don't even know. So wait till the end of this video to see. Now, what I'm starting with here looks like a plain old spinning cube, and actually that's what it is. What I want to do is not just make a plain old spinning cube in 3 dimensions. I want to make a hypercube spinning in the 4th dimension. So I want to make something that looks like this. All right, so this is a hypercube, otherwise known as a tesseract. And I'm going to, before I start coding any of this, I'm going to explain to you what that is exactly. So let me come over here. So I think my favorite dimension is 1 dimension. Oh no, 0. Let's start with 0 dimensions. A point is a shape that exists in 0D. That's a 0. Now, a line, which is bound by 2 points, is something that exists in 1-dimensional space. This is 1-dimensional space. A rectangle, a square, a plane, which is bound by 1, 2, 3, 4 lines, exists in 2-dimensional space. Now, notice a pattern here. This is bound by 2 lines. This is bound by 4. This is bound by 2 points. This is bound by 4 lines. Now, if I create 2 planes, and then connect all the edges, I have what is commonly referred to as a cube. This is something that exists in 3 dimensions, are the number of dimensions that we live in on this planet where we live, and it is bound by 6 planes. So you can see a pattern here. I was going to say you double it, but this is not bound by anything, I guess, so that sort of makes sense. This is bound by 0 things. This is the beginning. Now, what does it mean then to have 4 dimensions? Well, I'm not really going to be able to draw this too easily, but we could make the case, right, if I'm following this pattern, that 4 dimensions is bound by 8 cubes. And this is mathematically true. This is accurate. The problem is, I'm going to sit here and I'm going to visualize this in my head. Are you doing this with me? I can't. I just cannot do it at all. Human beings are not, we did not evolve to understand the world in any dimensions higher than 3. Anyway, I could keep going on about this, but since this is a mathematical truth, why isn't there a way that we could somehow unlock it and see this on our computer screen in some way? And in fact, there is. So this is how. How do we even see this? How do we even see this 3D shape on a 2D computer screen? Well, the way we do that is by writing code like this one that I've done right here. Now, the truth of the matter is, in processing, which is the programming language environment I'm using right now, I could just say box, and I would get that because I'm in the P3D renderer. And the P3D renderer knows how to take the mathematics of a 3D shape and project it into a 2D canvas to create the illusion of the 3rd dimension. And it totally makes sense to our brain because we're so used to 3D, we can imagine it. We can see the 2D version of it and imagine it in 3 dimensions. So, and I did you don't have to have watched that video to watch this one, but I did a whole previous coding challenge where I made exactly this, but only using the P2D renderer. So I did the math of taking 3D points and projecting them into 2D. So if I can do that, why can't I create the math for a 4D shape, do the projection into 3D, and render it with the P3D renderer? The truth of the matter is I could then project it into 2D and render it with the P2D renderer too, but I'm lazy. I'm just going to do one projection. And if this is true, there's no reason why I couldn't create a 5D shape and a 6D shape and a 7D shape. And I project 7D into 6D into 5D into 4D and then into 3D and visualize it. So this is what I'm going to attempt to do in this video. It is going to require matrices. There are ways to do it without it or to create the visual illusion of it, but I'm going to be using matrices. And the matrices are going to be used for a couple things. I need a projection matrix. This is a matrix that takes a 4D point and turns it into a 3D point. And I'm going to also need a rotation matrix. I don't need the rotation matrix, but the rotation matrix is what's going to make this fun because I can start to rotate around weird axes to see crazy things happen. So this is kind of like optional, but this is what's going to make the visualization. So I'm going to do the most basic wireframe version of this. And hopefully you are then going to make beautiful, interesting, weird things about this. And somebody watching this, who can go to the highest dimension possible in processing? I would like to see that as a challenge. Okay, one thing I forgot to mention, I really should have mentioned it at the top of this video, but, and I could record a new introduction once I have it finished. Oh, I guess I could just reference it now, is fine. Okay, nobody's complained yet anywhere. I'm getting a YouTube notification that the ukulele channel that I watch has a new video out. Oh, sorry, I'm just going to go and learn to play the song with the ukulele. Okay. If you are getting a ukulele notification right now, that means we watch the same ukulele channel. All right, so I think it's probably fine for me to just reference this video now. I meant to reference this at the top, but that's fine. So let me come back. All right. Now, if you want to learn more or see a sort of like condensed version of the explanation of what the tesseract is and how this works, I would highly recommend this. For me, I'm making this coding challenge because of this particular video from, how do you pronounce that? Anybody know how you say this? What's the chance, what's the chance that, hold on. Laos OS, Supreme, Leos OS, yes? Leos OS. Okay, hello Aram. Oh, I lost the channel. Oh, I'm in the wrong place. Laos OS. Laos OS. Laos OS. Is that correct, Alka? Why am I recording this again? Don't you guys know that I'm just Sisyphus? I just do the same thing over and over and over again. Laos OS. All right. Alka is typing. Oh, I'm just guessing. Oh! Yes. All right. Laos OS. All right, I'll just have to guess. I actually just messaged him to ask how to pronounce his channel, but I don't think I have a reply yet. Okay. Laos OS. Okay. Laos. All right. All right. All right. All right. All right. I gotta move on. All right. That's Tim. That's very funny. Tim writes Le Android OS. Okay. Okay. I can't figure out how to pronounce it. I'm gonna guess Laos OS. But anyway, this is a wonderful, wonderful YouTube channel with many excellent explanatory videos. And this one about understanding 4D, the tesseract, is excellent. So you can pause this, go watch that, come back later, all the above. Okay. All right, so now I think we're good. We're good. I'm gonna minimize the browser, and here I am. Okay. All right. Now, what do I need? The first thing I need to do, if I'm gonna make something 4D, to do something in 3D, I make heavy use of this idea of a PVector, which is a data structure that holds an X, Y, and a Z. I need something that can hold an X, Y, to Z, and a W for that fourth dimension. So I'm gonna make a new tab, and I'm going to call it PVector. And I'm going to say class PVector. And I'm going to say it has an X, Y, Z, and a W. And it needs a constructor. And it can get an X, a Y, a Z, and a W. And then I'm going to say X equal, oh no, this dot X. Isn't it fun when you have to use the this dot in Java because it's like so rare? And then every once in a while you do. Z, W, X, Y, Z, W. So now this is my PVector. All right, PVector. There we go. And now I am going to make this cube, this very cube, all the points of the cube. And actually, one thing I want to do, I'll leave it right now. I'm going to make it in 4D. 0, 0, 0, 0, 0, 0, 0, 0. The fourth dimension! And then, while I'm adding the fourth dimension, I got to change these, PVector. Okay. Then I've got to change this, PVector. And now, okay, this stuff I'm going to worry about later. And let's see, we're going to watch, it's going to be 4 dimensions now, everybody. Here it comes, 4 dimensions. Look away! Ah! Okay. So this is the same exact cube, right? It's the same. Is that 4 dimensions? Oh, I'm so confused. Huh. Well, how are you going to see this 4th dimension? Well, first of all, all of the points are on 0. So what you can think about it is it's flat. I took a 4-dimensional shape and flattened it. Flattened it. You know, we say flat because usually we're taking a 3-dimensional shape and flattening it into 2D. So a cube, if you flatten it, would just be a square. So I took this hypercube and flattened it, and I just have the cube. So I need to make the hypercube. Okay. What I'm going to do is I'm going to make, all right. Oh boy, oh boy. You know what? I'm going to, against my better judgment, I'm just going to extend this array to have 16 points, right? A hypercube is made up of 16 vertices because it's basically 2 cubes with all the points connected. So I was going to make like a cube object, and a hypercube is 2 cubes, but I'm going to just keep going. So I'm going to say 8, 9, 10, 11, 12, 13, 14, 15. And then I'm actually going to put this in 4D. So all of these zeros, right, these should all be 100. These should all be 100. And then I'm going to put the rest of them at -100. I know I'm doing this in a highly manual way, but first of all, I find it kind of relaxing sometimes just to see her copy paste the same thing over and over again. You should try it. It's very soothing. And then also, I can always refactor it later, but just to like really know that it's working. Okay, so I've got 16 4-dimensional points. I am going to now draw them again. Okay, so it still just looks like those points. What's missing here? Well, I'm not actually doing the projection. So now it's time for me, like I'm just taking the 4D point, ignoring that v.w part, and then doing a projection. So really what I need to do right now is think about how I do the projection. So we have this idea of a projection matrix. Now, I'm not going to go too much into detail of this. You can watch my previous video where I made the 3D projected into 2D. But basically, the idea here is that if I have a 4-dimensional point, x, y, and I'm drawing that way too high. Did the camera get lower at some point? Like, I don't know. I'm going to leave the camera there because probably, did I just mess up the focus? Just get. I'm going to, I forgot what I was saying now. I'm going to create a projection matrix for a 4D point. So this is the point x, y, w, z. The projection matrix to take a 4D point and turn it into, x, y, z, w, and project it into something that I can draw into 3D, x, y, z. The idea is like I want to look at the shadow of the 4D object in 3D, just like I might look at the shadow of a 3D object in 2D. So to do that, I need a matrix that has 4 columns and 3 rows. So the typical way to do that would be like this. 1, 0, 0, 0. 0, 1, 0, 0. 0, 0, 1, 0. Right? I think I got everything. The idea here, if I actually use this matrix and perform matrix multiplication, which I'll link to 2 videos where I go through that in more detail, this actually gives me literally this. It's like just chopping off the W. So let's actually put this in our code and see what happens. So I'm going to create, So I'm going to create a matrix. Now, one thing I didn't mention is I'm working with a set of helper functions. And I work these functions out in a separate video if you're interested, but it's too much. It's way too much to be in this video that has actually the matrix multiplication math in it. as well as some helper stuff to do matrix multiplication with a matrix and a vector. I'm going to have to change this to P4 vector, I'm just realizing though. But that's no problem. Okay, so what I first want to do is create that projection matrix. So I'm gonna do it. I'm just gonna do it right here as a local variable, and maybe a little bit later it'll sort of make sense why. So I'm gonna say a float projection equals. So I need to make that matrix, which is an array of arrays. So there are 3 rows: 0, 1, 0, 0, and then 0, 1, 0, 0, 1, 0. This is the equivalent of orthographic projection, if you've heard that term before. Okay, so now we've done that. Then what I'm going to say is P4, actually PVector. I don't need it to be a P4 vector. I'm taking the 3D point. PVector projected equals matrix multiplication, the projection times V. Okay, so now it's telling me it doesn't know how to do matrix multiplication with a projection matrix and V, which is a P4 vector, which is strange because if I go in here, it has a function with to matrix multiply a 2-dimensional array and a P vector, but I need this to be a P4 vector. Okay. Vec to matrix. Doesn't know how to make a P4 vector. So I'm just going to change these functions to deal with 4D, sorry. M 3 equals V W. So again, if you want to see where I have a separate video where I wrote all this code and now I'm just adjusting it to add this 4th dimension. And then matrix to vec is going to be, yeah, you know what? I'm going to always be doing this. This is fine. This stays the same. So that stays the same because I still want, what I'm going to get is a 3D vector inside a matrix, and I want to turn it into a P vector. So let's see. So nobody's complaining at me. And now I want to look at the projected points. Projected, projected, projected. Here we go. Ooh, what's wrong here? Vec to matrix. Array index out of bounds exception. Where I have an error somewhere. Where is this called? Here. This has to be a 4. This has to be a 4. So I forget that I'm in Java and I really have to specify types and lengths of things. So that has to be a 4. Is there anywhere else where I need to do that? We'll find out soon enough. Okay, let's try this one more time. We're entering the 4th dimension. Whoa, okay, it's still the same. Why? There are 8 points in 4 dimensions. Well, guess what? If I took a cube and I showed it to you in orthographic projection facing the camera, basically, it would look like just 4 points. The 4 points on the back of the cube would be sitting right exactly behind the 4 points at the front, and you wouldn't see them as different. Same thing is going on here. So what I actually need is not orthographic projection. I need stereographic projection. I need to create that perspective. And the way to do that is with moving sort of thinking of a light source that has a certain distance from the object that I'm casting a shadow. So I'm going to create a variable, distance, and this is going to be, one thing I really should do is I'm going to take all these 100s and make them just the number 1. So I'm going to normalize my shape to just have all 1s. This looks like a completely insane person wrote this code. And in fact, a completely insane person did write that code. That way, so I'm going to think of the camera as 2 sort of units away. And then the projection, W, is 1 divided by that distance minus V dot W. This is a sort of tried and true formula for creating perspective projection. And then I can put that W in here. And now, let's see what happens. Oh my God, do we have 4 dimensions? Oh, I forgot. Oh, I'm so close. I'm so close. So I forgot that all my numbers are 1. So I'm just going to scale. There's a variety of ways I could scale things up, but I'm just going to do it right here. So I'm going to multiply by 100. And now, oh, look at that. What kind of looks like sort of looks like that tesseract thing. Wait a second, wait a second, wait a second, wait a second, wait a second. Oh, this is crazy. Oh, I got to connect the lines. So first of all, I need more. I guess I should make this smaller. Let's make this 50. Do you see it? That's that tesseract-looking thing. The fourth dimension. So what is it? So your brains can't do this. Connecting it will help. I'm going to connect all the lines. Let's do that. So I'm going to, so I had a function that connects all the edges. I think I did this in the video where I was just making a cube. And these are P4 vectors now. Oh, no, they're not. They're still P vectors. And so, but I need to connect the, I need to make, all right, everything's going to be okay, everybody. I'm going to make an array, P vector projected, projected 3D, which is an array, is a new P vector also with 16 points in it, and I'm just going to take projected 3D index I. There's no index. I'm going to add an index because I'm using this enhanced loop. I probably should just make it a for loop. Let's make it a for loop. I got time to do that. You'll watch me do this. For int I equals 0, I is less than points.length, I plus plus, and then P4 vector V equals points index I. So I'm manually iterating through it because now I can have this index. And then with this index here, I can say equals that projected V, projected. And then I could still draw these here, but now I can say projected 3D. So I want to connect the various points there. And so now I should see, oh, that's just one. Oh, right, because I got to do this twice. Oh, no, I got to do this all the way. Oh, this is confusing. I got to use the second half of the array, which would be from like 8 to 12. I don't know. Oh, I equals 8. That's not right. 7? 0, 1, 2, 3, 4, 5, 6, 7. 8. 0 to 4. Because if I want all the... Oh, modulus. Oh, modulus 4 plus 8. Oh, I've made a horror show out of this. Oh, it went out of bounds. Stop the presses! I have to rethink this before I do the connection stuff. Is like I should do that from scratch. Let me take the connection stuff out. I think that's going to be way too confusing. And I can go back. Although, let me just go back here. So this worked, right? If I just had two separate, I should just make two separate arrays. Trying to think, what's the best way to explain this? Oh, I just had one off? Okay. Okay, let me stop here. Let me go from here. I said, okay, I now realize that I try not to do this. I try to have my videos be very self-contained, and there's a few things that you might have to watch a previous video for, but I think it's worth explaining this just for a second. So basically what I did in this connect function is this is a connect function to just take two of the points and draw a line between them. And to draw a cube, right, normally I might just say box or begin shape, end shape, and it's going to sort of like make all these connections for me. But what I'm doing is I basically have points 0, 1, 2, 3, 4, 5, actually it's 0, 1, 2, 3, 4, 5, 6, 7. So that function is basically saying connect 0 and 1, connect 1 and 2, connect 2 and 3, connect 3 and 0. connect 4 and 5, connect 5 and 6, connect 6 and 7, connect 7 and 4, and then connect 0 and 4, 1 and 5, 2 and 6, 3 and 7. That's what that function is doing. And so now I have two of them. If I have another one, basically, you know, it's along the four-dimensional axis. I don't even know where to draw that. So first of all of its points start at 8, 9, 10, 11, 12. And this is not, somebody watching this will give me some nice suggestions about how to completely refactor this in a better way. But you can see now I just need to connect these. So the way that I think I'm going to approach that is by, I'm going to add another, I think if I just add like an offset, like I can add an offset, this is kind of silly, here, and then that offset could be 0, and then that offset could be 7, right? Because then I just want to do this, and so this would just be I plus offset, j plus offset. So if I do this twice, and again, I could do this in one loop, right? I could add an offset that's 8. Is it 8? I think it's 8. There we go. Ha! So now you can see I've connected both cubes. So now, interestingly enough, what's the fourth dimension with this kind of perspective? The fourth dimension is actually W. W is expressed as kind of the distance between these cubes. I mean, again, we can only think about it, I can only describe it to you in three-dimensional terms. For example, you see this here, like if I were to put one of these points like at -5, look, it's all the way out there. So this hypercube isn't perfectly symmetrical. One of the points, its W location, is all the way out along that axis. And I could make that as a variable, and I could slide it around and do stuff like that. But I'm not going to do that. What I want to do next, so one thing is, I really want to make all the connections. So the nice thing is oh, I'm tripping. I really want to make all the connections. So the nice thing is the last set of connections is pretty easy. Oh, oops. William Westner says, I've never once seen a good tesseract representation. Everyone gets the occlusion wrong. Am I getting the occlusion wrong? I'm just doing what everybody else does. Oh boy, everybody's giving me suggestions. Okay. All right. All right. I forgot what I'm going to try to back up, even though that's probably unnecessary. All right, what I really want to do is I want to see all the connections. It's going to be, I want the edges of one bounding cube need to be connected to the other bounding cube. They're not really bounding cubes. Oh, it's so confusing. I haven't actually finished the connections though, because what I want here is I need to connect all these points to those points for the visualization to be fully complete. That's actually going to be pretty easy, because all I'm doing in my array of 16 points, 0 connect to 8, 1 connect to 9, 4 connect to 12, 5 connect to 3. So that's actually easy. That's just another loop all the way through all the points. And I'm going to have, with an offset of 0, I connected to I plus 8. So this should do that last set of connections. Oops, no, something's wrong here. Oh, no. I need to go through half the points because the first half are connected to the second point. All right, is this right? This looks right to me. Oh, why is it going towards the center? Something is wrong here. Okay, something is wrong. Let me think about this. I goes to I plus 8. Did I do them in the same order? Pretty sure that I did. This is the problem when you do things manually. What's wrong? Something is wrong here. Let's take out these connections and these connections. Maybe that'll help us see it. Yeah, what's wrong here? Anybody have any idea? You connected 0 to 13, 2 to 12. 0 to 8, 1 to 9. Opposite vertices. Oh. Oh. Oh, yeah. Loop through every vertex and calculate the distance to the other vertices and connect the ones with distance of 1. Oh, that's really smart. Oh, that's really smart. Oh, what an awesome idea. I'm connecting to the furthest corner. So what is it? Is it like 16 minus I or something? Plus 1? No. A minus 1, I mean, which would be 15. No. That's not right. That's closer. All right, let's just, let's figure out. So 0, let's connect from, so 0 to 8 is there. Ah, yeah. So that should be 0 to 4. No, not 0 to 4. That's 0 to 12. 0 to 6 to 15. Is that right? No. 0 to 11. I just keep guessing vertices. Oh my God, I'm losing my mind here. 0 connects to that one, which is, which one is it? Robert, can you see my solutions? Use the nearest neighbor idea. Ah, that is really a cool idea. 16 minus I minus 2. 15 minus I. 0 to 13. Everyone's giving me excellent suggestions. Draw index as text on vertices. That's such a cool idea. All right, let's try that. Text I. Always get stuck with these little things. All right. Oh, wait, hold on. Let's not draw the points. All right, hold on. Let's do rotate. Let me billboard them. Oh, whoops. Huh. Oh, because whoops, that's the rotation's in the wrong place. Sorry. There we go. Okay, and let me make the text size. And fill 255. Is that going to make it bigger? Okay. All right, so this, I'm gonna, Mathieu, this will be a part where I'll come back into the video. At some point it'll get cut and I'll come back to here because I think this is a good, because I can see it's 8 to 6, 9 to 7, 10 to 4, 14 to 0. I mean, I could just do the distance of one thing, which kind of makes sense. But, 0 to 14, 1 to 15, 5 to 11. Yeah, it's like a weird formula. All right. Okay, so I was debugging that for a little while and it was making me crazy. And so someone in the chat suggested just draw the points as numbers. So you can see I did this here. I actually added a little code to draw the index I. And so now I can look at this and I can see, okay, 0 should be connected to 14, 1 to 15, 5 to 11, 4 to 10, 3 to 13, 2 to 12. There's definitely a pattern there, but I think actually someone else in the chat, and I wish I could remember the chat scrolling back so fast, the name suggested, you know what? You just want to connect every vertex that has a distance of 1. So actually, this is a great idea. I can actually eliminate this entire nonsense loop, basically. And I'm gonna do that. Let's try that, right? So what I'm gonna say is for I'm gonna do a nested loop. For every I equals 0, I is less than points.length I plus plus. Then I'm gonna start with I plus 1, because I don't need to check a point against itself. J is less than points.length J plus plus. Now, what I need to do is calculate the distance between those points. So I'm going to say float distance equal distance 4D between, and let's just put those in P4 vector A equals, P4 vector A equals points index I, P4 vector B equals points index B. So I am now going to calculate the distance 4D between A and B. Oh, guess what? There's no distance 4D function. I will make one. I'm going to put it here on my helper function page. I'm going to say float distance 4D. I get a P4 vector vector A. This actually would make more sense on the P4 vector tab. So let's write this here. And I could obviously make it a function that's a part of the class, but P4 vector B. And so now what I need to do is I need to do dx equals a dot x minus b dot x. Dy equals a dot y minus b dot y. I'm going to do this pretty manually. Just the difference between all the dimensions. That's a w. This is just Euclidean distance, but in 4 dimensions. Then I need to say return the square root of dx times dx plus dy times dy plus dz times dz. And forget the fact that this is kind of inefficient. There's probably ways I could optimize this. It's going to work. So now, if d equals 1, then connect. And this function is so silly. I don't need the offset anymore. Shouldn't need that offset. Then connect I and j points. And these are not points. These are not the points at all. These are the projected 3D ones. Oh, wait a sec. No. I want the distance between the points. And then, I'm checking the distance between those points, but I'm connecting the corresponding ones in the projected 3D array. So this is to be P4 vector. No, this is PVector. Oh, it's so confusing. Points J. Projected 3D. Okay, right? I'm looking at the 4D values, seeing their distance, then connecting the corresponding ones. Let's see. Hey, look, it's all numbers. Hold on a sec, everybody. I must have made a mistake somewhere. So let me get rid of all this. Let me put this back to just the points. I want to believe that it's going to work. Okay, so the points are there. I'm not seeing any of the connections. Yes, I can pre-calculate the connections in setup. That is a very good point. Let's see, what kind of distance values am I getting? Is it doing some sort of rounding thing where it's not actually equal to 1? Yeah. Whoa, okay, so first of all, I think I meant to say 2. The distance is 2, because they're actually like, the distance is 2, because I'm from the center, along each axis, I'm extruding by 1 both directions. So the distance is 2, not 1. There we go. Ah, no, wait, it's still going through the center. Ah! Because I'm drawing them flipped? Yeah. Yeah. That didn't work. This whole swath is gonna get edited out. I guess I could just manually do the, boy, why? I was really thinking it would be so easy to connect. Our negative and inverted, Robert's like said this like 15 times. The problem is the chat scrolls by very fast. So unless somebody can capture something and put it into the smaller Slack channel, because I can't catch it. So they're inverted. I'm going to try to scroll back. There's 32 edges. So it should be like the opposite one. I should just made it 2. Yeah, I need to look at the projection. The projection point you're using is making the negative ones get projected to the opposite side of the 0 point. So could I actually change that in the projection? Like, some weird thing like this or something? Yeah, I can scroll. That's a good point. Just go back to the old message using 16 minus I minus 2. Oh, add 3. Perhaps the points value are correct, but they are represented rotated. Okay, I'm going to try to figure this out myself. All right, that was a nice digression. That was interesting to solve, but didn't actually do anything. Let me just comment this out for right now. Oh, wait. I need my connections back. I need my connections back. I deleted them. I was so confident. So hold on. Let me put this somewhere else. Just to save this. This was a digression that I'm going to go backtrack. And I'm going to go back, stop. I'm going to go back to where I just had the numbers. Let's see how far processing will let me undo. Ooh, not very far, huh? Okay. All right, I'm back to this. So, let me just allow myself to control this completely. I'm going to write these down. Isn't the distance between connection from between all 0, 4, 2 every time? Somebody will figure this out. Somebody much smarter than me will figure this out, and I look forward to that day. Okay, I'm going to come back. I'm going all the way back to where I was just explaining about the text. So you can just cut out huge amounts of stuff. Hi, that was a weird edit point probably, because I've been I just spent, and if you want to watch a link to the live stream where I just probably spent like a half an hour trying to figure out a pattern here, and I'm sure there is one, and somebody watching this video will come up with one. But what I did to debug this, I think will make our lives a little easier, is first, I just decided to write, instead of drawing points For all those points, I'm just drawing the index value of the array using the text function and translating to that projected location. And then I also just made the angle, the mouse X, so I can control this. So I can actually write this down. I'm going to get a piece of paper. Or I could put it as notes in my code. But I feel like a piece of paper would really be just like an exciting moment here on the coding train. If only I had like a whiteboard or something to write this stuff down. Okay. So now, let's look at this. 9 connects to 7. 10 connects to 4. I should really start with 1 or 0. Where's 0? Let's go in order. 0 connects to 14. That makes sense. 1 connects to 15. That makes sense. Or is that 11? No, that's 1. 2 connects to 12. The pattern is going to come up, I expect. 3 connects to 13. 4 connects to 10. We could speed this up, I guess, this part up. 5 connects to 11. 5 goes to 11. 6 connects to 8. And 7 connects to, what's the only one left? Should be 9, right? 9. Okay. Guess what? Here's a way to write this code. Now, guess what? Connect. 0. I still need that offset thing, right? 0, 0, 14, projected, 3D. Oh, this is lovely. Oh, this is so beautiful, this code. 0, 14, 1, 15. 2, 12. Yes, I'm doing this. 3, 30. I'm not looking at the chat. I don't want to hear it. I don't want to hear it. I don't want to hear it. I don't care. I'm going to make this tesseract the way I want to make the tesseract. 6, 8. Oh, you can see the pattern. I'm starting to see the pattern is coming into my head. 7, 9. And now, this looks good. This looks good. Let's put those points back in. Let's take out this text. I'm going to leave that in there, just like commented in the code. And let's put this back in. I'm going to just let it rotate automatically now. And we are entering the 4th dimension. Okay, we're finally ready for something exciting. Sort of. All right. So what's the deal here? Now look at this. How am I rotating that? The shape is spinning in 3D. I want to do 4D rotations. 4D rotations. So this is now the moment we're going to start to get something pretty interesting visually going on, where I now want to create not a projection matrix, but a rotation matrix. So here's the thing. In 2D, a 2D, I want to draw up here, but I don't think you can see it, so I'm going to draw it here. If we go and I'm going to go to a Wikipedia page, rotation matrix. We're going to see that a rotation matrix looks something like this. And I'm going to write this down, duplicate this over here, because we're going to kind of want to memorize this. It's cosine of the angle, a negative sine of the angle, and then I already forgot it, sine of the angle, cosine of the angle, right, of course. And if we were to take this rotation matrix and multiply it by an xy point, this is basically doing regular plane rotation in two-dimensional space based on an angle. And that's what happens when you just, in P2D, you just call rotate. It's applying a rotation matrix like this. So if I scroll down further onto this page, we can start to see, oh, look at this. I've been scrolling, oh, look at this. These are like 3D rotations. Around the x-axis, we put a 1 in that first spot, and then we have that sort of like 4 rotation values in the bottom right, because it is rotating around the x-axis using the y and z axes. This is rotating around the y-axis using the x and z. So this is the idea that I need to extrapolate to 4 dimensions. So now, if I want to rotate in 4 dimensions, I would just put cosine theta negative sine theta 0, 0, sine theta cosine theta 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. This is the idea. This is now a rotation matrix that will rotate. You can see, that will rotate around the x using the xy axes, x and y. No z, no w. So this should look sort of familiar to us if we apply this in the code. So let's go to the code, and I'm going to. This is the important part, right? This is where I'm doing the projection. Now I want to rotate before I project. So I'm going to create a P4 vector. Oh boy, we're going to need some more vector math stuff. Rotated equals matrix multiplication, a rotation matrix times V. And my rotation matrix, I'm going to copy paste this, and I'm going to make a rotation matrix. It's going to have cosine of the angle, negative sine of the angle, sine of the angle, cosine of the angle, a 1, and then a 1. This is, I'm sticking with 4 dimensions here, right? So this should give me a 4D point out of it. I'm just rotating that 4D point according to the xy axis. All right, the problem is my nice, beautiful matmul function doesn't know how to. Let me stop for a second. I can't overload this. I want this to be matrix to vec 4. The projection is missing the brackets and it makes me sad. The 4th rotation is wrong. Okay, all right. Hold on, I need to work out the matrix multiplication, but everybody's blaring at me that I have mistakes in my code separate from that. So let's fix those. This is wrong, thank you. This needs to be a 0. And then in the projection, something is wrong in the projection. Your projection is missing the brackets and it makes me sad. Where? Yeah. 0, 0, 0, 0, 0, 0, 1. All right, I fixed that 0, 0, 1 thing. You guys are so far behind me in time. Me, I am, so me is typing. W equals 1 divided by distance minus. Oh, that's been wrong all along? Parentheses. We call those parentheses. 449. Okay, another like a little weird edit point. I just fixed this mistake, and then I was like sitting here, and I was like, this is like a major error. I don't know how it happened to work. Those parentheses need to be there. This formula has been wrong for a very long time in this video. I'm so sorry. I'm so sorry. It's fixed now. Let me, for a second then, just get rid of the rotation and just make sure everything still looks kind of normalish. Okay. That's what was messing up those connections. Could that really be true? Well, I'm going to have to go way back in time. It was interesting, that digression, though, to like debug it in that way. That was useful. Don't mind me, I'm just over here checking something. Just ignore me, just over here checking something. Oh. If I could turn back time. Okay. This is a good thing because the actual finished version of this video there was a point. So here's the thing. In theory, I'm gonna just go back. I'm gonna take this out. These were nice, interesting digressions. I hate to lose them, but I'm losing them. I'm gonna put this mistake back in. So this is the point I need to go back to. Oh, do the 2 distance thing? So now I could do the 2 distance thing. This is actually the point I can go back to. Don't go back. I'm not going back, really. I'm just going to excise all that out of the final edited version of this coding challenge. Which will be sad, I guess. And I could do the nearest neighbors. Yes, I know I could do the nearest neighbors stuff. I will mention that. Oh boy. All right. Oh, hello. No, I'm not going to do the oh, hello thing. That's too much of a cliche. Okay, I'm going to do this. This will work well. Okay, so that was like a very abrupt edit. I will link to the live stream where I'm currently right now live doing this coding challenge. I've just probably edited out about 45 minutes of doing all sorts of crazy debugging. I was doing some stuff where I was putting numbers where they were, trying to figure out the connections. And there was actually just a bug, which you may have already noticed and been typing in the comments or shouting at me or maybe just singing it to me in a lovely, friendly way. This was a mistake. This here, this formula for doing the, this formula for doing the perspective projection needs to have parentheses here because I'm saying 1 divided by the distance from the camera minus the actual W point. Not 1 divided by distance minus the W point. That's the actual formula. You can go watch that. Every other material about that, you'll find that formula. Okay, so now if I do that, now this looks like I expected it to look like. And in fact, during that time, I also tried a different solution, which I would recommend doing as an exercise to yourself. One thing that was pointed out by the chat, oops. Let me just. Oh, nice, I was AFK for 45 minutes. You know what, since the camera went off and I alt-tabbed into this page that I didn't mean to alt-tab into. Once more with feeling. Once more with feeling. Hello. Okay, so that was an abrupt edit. If you're not watching this live, you're watching the recorded version. I just spent about 45 minutes trying to debug a problem when I went off completely in the wrong direction. Well, it was a really interesting, lots of interesting tangents. I encourage you, I'll link to the time code of the live stream where you can watch that whole part. But I was trying to figure out why these points aren't connecting properly, and I started doing things like drawing numbers where all the points were and all sorts of stuff. But actually, the mistake, which you may have already seen and been singing to me about it, perhaps, is right here. There needs to be parentheses here. The formula for the perspective projection requires 1 divided by the distance minus the actual W point. As soon as I put that in, now all of the points are in the right place, and those connections are doing what they should do. The actual drawn points are a little bit too large for my taste right now. I'm going to take this to 8. And this looks better now. Okay, so there we can see there's our hypercube in 3D, sort of. Okay, I gotta take a deep breath here because there's a lot of stuff and I gotta figure out where I am. Oh yes, rotation. Okay, pause for a second. Somebody actually sponsored this. Thank you, Alec Baroff. Okay, so here's the thing. Oh yeah, so okay. Before I get to rotation, actually, let me just mention one more thing about this. It was pointed out in the chat by many people that instead of like trying to write some kind of kooky, nonsensical, crazy person algorithm like I did here to figure out where all the connections are, that you could actually just test for unit distance between the points, right? Because if you think about a square, right, you don't connect the diagonals because they're not distance, they have a different distance. So if I look at the distance between all the points, I'll find all the connections there. So that's an interesting side project for any of you as an exercise to do while you're watching this. But I want to talk about rotation now. I already talked about rotation, but it was while I was debugging. I got to talk about it again. So there's some stuff written on the whiteboard over there. I never go erase it. Pause. Oh, this camera's off. So I think I have to do the rotation explanation again because I don't see any other way of approaching it. Because now that I have it fixed. I mean, we could edit out of order time sequence wise, but this is going to be a big project. Good thing I'm going away. By the way, I'm going away for like 3 weeks, so Mathieu will have a lot of time to edit this. I also could just start over and do it again, but I think this coding challenge. So what was in here before? It was just the projection matrix. Okay, great. Okay, here we are. All right. So how is this even rotating in the first place? How is it rotating in the first place? So I like that thing where I moved the point out. Yeah, it made sense. Okay, I think that's in there. Sorry. All right. Okay. So how is this rotation even happening in the first place? I'm rotating in the third dimension, which is not really what I want to do. I want to rotate in the fourth dimension, then project that down to the third dimension. So let's try to back up. Let's try to create exactly this by rotating in the fourth dimension and then projecting back down to the third dimension. The reason why I'm not actually doing the rotation in the fourth dimension is because the rotation is happening right here with the built-in native rotate y function. That means rotating around the y-axis. So how does rotation actually happen? Well, rotation happens with a rotation matrix. So here I am on the Wikipedia page, and you can see this rotation matrix right here. So let's come back over here, and let's think about that. So this is a rotation matrix. Cosine of theta, negative sine of theta, sine of theta, cosine of theta. Did I get that right? Looks like I did. All right, so this is a 2D rotation matrix. If I were to take this rotation matrix and do matrix multiplication with any given 2D point, this is exactly the math behind rotate in processing by theta. This is exactly that. So then, what is the math behind rotate y? Or rotate x, or rotate z. And in fact, it is indeed also a rotation matrix, only it's 3 by 3 rotation matrix. And in fact, if I come over here on this Wikipedia page about rotation matrices and keep scrolling, keep scrolling, and keep scrolling, and keep scrolling, there we go. Here it is. This is the rotation matrix for around the y-axis. And you can see a pattern here, right? That's that 2D rotation, but it's here within the y and z, which is rotating around the x-axis. Same pattern, but between the x and the z, between the x and the y. That's how I get all those different rotations. But I want to do this in 4 dimensions. So what I need to do rotation in 4 dimensions is the following. I need to pick which axes I want, and I need a 4 by 4 matrix. And in this case, the axes that I want, I'm going to use the x and y axes. And I'm going to say cosine theta, negative sine theta, sine theta, cosine theta. So this is, oh, and this has to be a 1, apologies, and this has to be a 1, right? Because it's the identity matrix for y and z. basically. Identity being just a 1 in those areas. So I don't know if that's actually the right way to phrase it. But anyway, so this is the rotation matrix. I'm going to call this, for 4D, this is rotation xy. So let's, and actually what I was doing, rotate y would be xz. But anyway, let's come back and now try to add that in. So what I'm going to do now, go back to my code. Okay, I'm going to comment out the rotate y. And instead, oh, look, it's already in there. Take that out, because I forgot I did this earlier. Hold on. I'm going to go back to my code, and I'm going to comment out this rotate y. So now there is no rotation for free from processing. I'm just seeing the Hypercube, the 4D Hypercube projected into 3D. I am going to create, whoops, this shouldn't be here. One more time with feeling. Okay. All right. I come back to the computer. I'm going to comment out rotate y. So now there's no rotation. And actually, I'm going to start with, just to be clear, I'm going to start with rotate x. No, rotate z. I think that'll be the simplest. So I'm going to start with rotate z. So I'm going to recreate exactly this. This doesn't look super interesting because of how flat it is, but that's what I'm going to start with. So let me, because I think that'll be the easiest one to do. I want to recreate that with a matrix. So the first thing I have to do is, before I do the projection, I have to create a rotation matrix, and I'm going to call this xy rotation. And that is going to equal a matrix that has, I forgot already, cosine of the angle, negative sine of the angle, 0, 0, sine of the angle, cosine of the angle, 0, 0, and then 0, 0, 1, 0, 0, 0, 0, 1. So this is my rotation xy matrix. Auto format, there we go. Rotation xy matrix. Now, I want to say, oh, you know what I can do here? Actually, sorry, I'm thinking. Oh, Leos OS. Thank you, Leos OS is in the chat. I'm sorry, I mispronounced your name, the name of your channel earlier. Apologies for that. Maybe we can dub that in. Or if I end up doing another intro to this. Okay. Okay, so now what I need to do is I need to say PVector, right? I want to get a rotated point, which is the rotation, which is the matrix multiplication result of the rotation matrix xy with v, that point v. Now this is telling me it doesn't know how to do this. So remember I have all those helper functions. The helper functions do these matrix multiplication operations. Well, I do have a helper function that does, it does, look at this. It does, I was like, oh look, it does this. A matrix times a P4 vector, I have that. But look at it, it returns a P vector because I have the 1 to give me a 3 P vector back. I should probably just leave everything as P4 vectors. It would make our life so much easier. There's not really any reason for me to use P vector at this point because I could always, but I've done what I've done. We can think about refactoring it later, which is like a little bit of my mantra. And I'm going to say, this still works. So I want to say if, so this is matrix to vec. I need another one of these, which does, I'm just going to write this function. I don't think I need this anymore because it's always going to have 3 dimensions. That was sort of an extra thing. Just to simplify this, I'm going to make another function that's going to be called matrix to vec 4. And I'm going to make a P4 vector. And then I'm going to say v.w is this. So I made a different function, and this returns a P4 vector, P4 vector. So I just made a helper function that takes a, oh, I don't have that, 0, 0, 0, 0, that basically takes a takes a matrix that has one column, right? This is what it is. It's a matrix with one column and 4 rows and turns this into a P4 vector. I need that because down here I now want to say, I'm going to say result equals mat mul A and M. And then I'm going to say if result.length, so how many rows? Do I have 4 rows or not? Equals 4. Then return. Oh, no, wait, I can't have it return 2 different types. I just have to do this. Java is a weird place, right? I can't return something of a different type. So I'm going to just pass a Boolean in. I'm going to pass our dimensions, like int dim. So I don't even need to figure it out. If dimensions equal 4, oh no, it's the same problem. Oh, I can. Oh no, I could just overload it. All right, I'm going to overload. Sorry, everybody. So this is. Sorry for this digression. This is making this video extra long. Yay for me. This is what it was before, right? Returning a matrix to vec. Oh no. Return. Sorry, everybody. There. This is what it was before. Now what I'm going to do is I'm going to just, this is very awkward, but I'm going to add, I'm going to say a Boolean or fourth. This is sort of silly. And now I'm just going to say matrix to vec 4, and it returns a P4 vector. Okay? So I made 2 versions of this function. This is very silly. I should have just made but it is what it is. Oh, okay. Can we get back to what we were doing, which was important? So now I'm going to say matmul rotation xy true. So this should return a 4D vector. Then now I want to get the W of the rotated vector, right? Because I'm about to calculate the projection matrix. I don't want to use the original point. I want to use the point that's been calculated after the rotation. And now we should see. Wait. Sine of angle. P4 vector. Or what did I do wrong? Aha! I projected V again. So this down here needs to be rotated also. There we go. I have now created exactly Z rotation with my own rotation matrix. Oh, we're getting really close, everybody. This is very exciting. So now I have a rotation xy just to prove a point. Let's do rotation. What was the one we saw with it spinning like this? Let's do rotation xz, meaning a 0 goes here, meaning a 1 goes here, a 0 goes here. This is how I like to. Now let's look at this. Is this right? I think this is rotation with x and z. 1 in the y and 1 in the w. So let's now change that to xz here. And look. There we go. I have it just rotating around what looks like the y-axis. Okay, this is exciting. Now watch this. What if I want to apply more than one rotation? So here, I've rotated by xz. Now I can just rotate again by rotating by xy. What's wrong here? Multiply rotation xy by rotated true. So I don't want to redeclare the variable. And here we go. Now we see both rotation. Okay, but everything still feels very much like all I did was make 2 3D cubes and connect the corners. So that's what you're seeing, right? Because that's the shadow of what the 4-dimensional shape in our only way our brains can process 3D. But let's really try to stretch our brains for a second. What if I include, this is really where things are going to go nuts. What if I include The w-axis. What does it mean to rotate around the w-axis? Think about that for a second. Okay, rotate around the y, rotate around the x, rotate around the z. It can't even, that w-axis that was kind of like extruded. Who knows what that's even going to be? Let's see what that looks like. We are now really about to enter the fourth dimension. Okay. Let's try, what do I want? XW? I don't know what's a good one to start with. Let's try XW. So I'm going to make a rotation matrix XW. Okay, here we go. So X, then a 0 goes here. Then that stays the same. Then this should be in the bottom, and a 0 goes here. Get rid of this comma, get rid of this 0, and then the 1 goes here. So let's actually, just for, I'm afraid to add too many rotations. So XZ, let's do XW, and then let's comment these out. So I am only using rotation around the XW axis. We're entering the fourth dimension. This isn't right. Something is wrong there. It did something interesting, though. All right. What's it that... Oh, you know what most people do, I think, actually, is not ZW. So let's do ZW. So let's put this here. And then these go away. I mean, I just want to see that I'm doing this correctly. And then this would be 1, 0, 0, 1. So let's try ZW. And let's see what this does. Okay, this is actually correct. Now it looks really weird, but I think I'm going to be able to fix this. I'm just going to do something really quickly, just as a test. Just want to like rotate it on its side. Maybe this side. No, something is still wrong. I've done something wrong. All right, I'm looking at the chat. YW, rotate it a bit around. Yeah, I've done something wrong. Cosine, negative sine, sine, cosine, rotation ZW. You know, this really shouldn't matter, but I just want to check something real quick. Oh boy, I just changed every number 1 to, that was a bad idea. We don't do that. Hold on, I just broke too many things. Because if I'm worried about that, I could just make this. Okay, what have I done wrong? Projection. Yeah, so let me do what is typically seen would be this now. It's not right, though. It's interesting. Unless I actually am... Oh, wait, take this off. No, something is off. Let me look at this other example I made the other day. I'm not sure about my vertex. I'm not sure about anything. People are asking, are you sure about rotate x negative pi over 2? Oh, I just was looking at it from the wrong direction. Weird. Huh. Thank you, Mr. Wiggles. XZ is wrong. So now I've got it. Order matters. Oh, order matters. I mean, I should just do this in one rotation matrix. Yeah, same thing. Interesting. Line 64, you still have a V. Well, it's working now. I just don't understand. Oh, whoa. No, that's right. So the first rotation is off of V, and then I just continue to rotate. Yeah, so it's just, I'm looking at it. This wasn't what I saw when I originally did it, though, was it? When I originally did it, see this? No. Oh. I lost track of where I was. I mean, don't get me wrong. I was just going to do all the rotations. X, Y, X, Z, Z, W. We could just keep going with craziness. Hold on, I'm going to wait till the sound dies down. Color the points and lines. That would be nice. No, I'm just noise in the hallway. What time is it? It's only 6 o'clock. I'm just trying to think of where I should go back to. Because there was the point where what I want to go back to is when I thought I did the fourth dimension the first time. Oh, maybe that was just this. Weird. Yeah, I definitely want to make the rotation interactive and everything. I'm just trying to think. I don't know where I don't remember where I was. I can go back. I can look. Could someone go back like 10 minutes in the live stream? I was trying to do X, Y, and Z, W, right? When I did X, Y, and Z, W, wasn't that where I said I'm entering the fourth dimension? And then did I try to, and it was that, but then did I do this? I'm like trying to find the place where it like looked almost, oh yeah, this is where I was. Okay. Yeah, I just went to the wrong side. Got it. All right. Okay. It's just the viewing angle. Yeah. Okay. Okay, so guess what? This is actually correct. I just have the wrong viewing angle. So like, basically what we're doing right now, if I just do the two rotations, sorry. I just have to, let me start over again. That noise is so distracting. Give me a second, people. So, Okay. Yeah. Sorry, I'm just waiting for the sound to die down, which might be a lost cause. Let me take a look outside. Okay, that's a lost cause. There'll be sound in the video. That's no problem. Okay, boy, this was a hard problem. Now I understand why people who make YouTube videos, they like script things and practice. They take like a whole week to make something. Someday. Okay, so I'm back again. I was trying to figure out why this is wrong, and then I realized, oh, this is actually right. I'm used to seeing a certain pattern, and I've just got the viewing angle slightly wrong or slightly different. So basically, let me comment this line, rotate Y out. The two rotations that I'm doing right now are X, Y, Z, W. And if we do that without just natively the way that I drew the cube, you sort of see the Z rotation and that W rotation in the projected into the 3D world is like kind of coming in and out. Almost looks like breathing. And so what I actually want to do is just rotate it on the X-axis to put things on the side. And I could do that with a rotation matrix, but because I have a full 3D renderer, I'm going to say rotate X, negative pi divided by 2, and there we go. Now this should look like the tesseract visualization that you're used to seeing. This is that W rotation, like rotating. And by the way, like we have now entered the fourth dimension. You know, it's a little bit anticlimactic, I guess. But here, we're done. This coding challenge is complete. And I just want to stop. I'm not going to do any more because I'm going to leave this for you. Let's think about, let's think about all the kinds of things you could do to this to make this more beautiful or interesting or weird. First of all, what are all sorts of other rotation matrices you can apply? Like what's like a 3-axis rotation? You could certainly do that, right? How many, this is a double rotation. Could you do a triple, a quadruple? What if you try a bunch of different other axes with the W axis? I'm just drawing these little points and connecting them with lines. There are probably so many other ways you could think to visualize the pattern of the tesseract. You can now enter the fourth dimension, project it into the third dimension, and see a result. I will try to make a JavaScript version of this with the P5JS library. It has a WebGL renderer. So that will be released also with this coding challenge. And there was something else that I just thought of a second ago. Oh! I will try to make a JavaScript version. I will also make a JavaScript version of this using the P5JS library, which has a WebGL renderer. Although in theory, I don't even need a 3D renderer because I could project the 4D points to 3D and then project the 3D points to 2D. If you really want a hard problem, try doing that. But really, I ask you, what dimension can you project down into 3 dimensions and visualize? Can you get up to 5, to 6, to 7? What happens? So I encourage you, I challenge you to try all sorts of weird stuff, to make some beautiful art, and enjoy spending time in the fourth dimension. Okay. That music better not get me a copyright violation. It says on the YouTube website that that's music you can use. Let's go double check. Let's find it. Otherwise, I'm going to redo this coding challenge again, which actually would be fun to do now that I know all the mistakes that I made. Mathieu might tell me I have to redo it, which I would totally understand. No, not here, not here. Not here, not here. Where did I close that out? Oh no, wait. Where is it? No, it's on the history audio library. Free music. What did I do? Genre, cinematic, mood, dark. It's this one. You're free to use this song and monetize your video. All right. So you heard it here. Okay. Well, I said I was going to make a tesseract. I made a tesseract. Now the question is, let's just I need a thumbnail. Let's make sure we have a good thumbnail. I'm sure there was something in there, but I just want to make it a little bigger. Let's do full screen, P3D, and then I'm going to, when I scale it up, just do width divided by 2. Let's see what happens when I do that. Ooh. What did I do? Oh, no, it's not, sorry. The function is full screen. Okay, that's not good. Let's try width divided by 4. That's close to what I was sort of hoping to see. Width divided by 8. Okay, that looks good. Now what? Do I want to, let's slow the angle down a little bit. Let's make the stroke weight 4 and the stroke weight like 16. Let's try this. Okay, there we go. And maybe we should make this. Is it actually better without the points? I just want to see what it looks like. I don't need to draw the points necessarily, right? Yeah, what do you think? Visually, do you like it with the points there or without the points? Mr. Wiggles, what did I miss? Different color lines. See, I'm just curious, what does this do here for a second? So that's kind of interesting. All right, I can't get, I'm going to let you be creative with color. Oh, stroke weight with distance to the camera, meaning distance to the W? Okay, I think I like it better actually thin with some points. This should be down here. Ooh, that's ugly. What if I give these like some alpha? What happens? That's kind of interesting. Okay, all right, so whatever, that's fine visually. I kind of want to add like another rotation. I'm just curious. Just curious. Okay. Let me just add one more rotation like, so if this is XY and this is ZW, why don't I try YW? Oh yeah, there we go. That is crazy. Just take out the if I just take out the ZW now. Ooh. Interesting. So many possibilities. All right, all right, all right, all right, all right. Nothing's happening now. I got tired and I started like distracting myself with, but I'm gonna, again, the world is a much more creative place than me. Go back to here and I'm gonna do a little intro. So how long would you say has been the total amount of time I spent building this in the live stream? And how do I say how do I say it again? That the YouTube channel from James, Leos OS, Leos OS, Leos OS. Okay. Okay. All right. So I don't know if this is necessary, but Mathieu, you can use it if you want. Hello. This coding challenge that you were about to watch. This is the final result. It is a 4D tesseract visualized in 3D. Also 4D, let me try this again. Hello. This coding challenge that you're about to watch, right here, this is the final result. It is a 4-dimensional hypercube, also known as a tesseract, visualized in 3 dimensions, but really in 2 dimensions on this 2-dimensional screen that you're watching this now. So, I just completed this coding challenge in a live stream. The live stream was about 73 hours long with a lot of debugging. The coding challenge itself is much shorter. It is kind of long, but a lot of stuff is edited out of like going off on debugging tangents. If you're interested in seeing all those debugging tangents, you can check this video's description to a link to the live stream where I did this. But also, I just want to briefly mention thank you to, I'm going to read it. This introduction is taking way too long. Leos OS. I'm going to try this one more time. Hello, you are about to watch, be careful, a coding challenge where I make this. This is a 4-dimensional hypercube. I mean, not really, but it is mathematically, it's a 4-dimensional hypercube projected into 3D, and then processing this computer program thing is taking that 3D math and then projecting it into 2D so you can look at it and see it. Anyway, if you watch the whole coding challenge, what I just said there might actually make sense to you. So it took me a very long time to do this. I had lots of problems. What you're about to watch is still long, but edited down. If you want to see the full live stream, which is 3,422 hours long. You can find a link to that in this video's description. Also, a big thank you to Leos OS, the YouTube channel where there's a wonderful video about what is 4D, the hypercube. I will link to that in this video description as well. I mentioned it also during the coding challenge, but I wanted to mention it right up front, okay? I hope you enjoy this coding challenge. If you make it all the way to the end and you make your own version of this, please share it with me. Goodbye. I mean, not goodbye, but goodbye right now for me, and I'm gonna keep going. Goodbye, I guess. Okay, all right. I am tired. I need a moment. I'm gonna put on some music for you all. I don't know what this one is, some other free music I downloaded. Gonna really build out my soundboard. And I'm just gonna check. I'm gonna check just some things and see how much time I have, if there's any emergencies. Just checking a few things. Just making sure there's no urgent messages for me from any of my other lives. Oh, there was a message that I missed. What time was that message? Can't see here. Is this relaxing you, this music? I don't know where I put my phone. Oh, well, that message was from over an hour ago. Okay, but I did reply to it. All right, I'm trying to decide if I have the stamina or energy to do anything else today. Let's take a look at some ML5. Let's consider some other ML5 stuff. I don't have my ukulele, otherwise I'd do my ukulele tuner. The feature extractor is too much for me to take on right now. I think I probably should call it a night. Let's see here. I think I have, PoseNet would be fun to do. This is PoseNet, by the way, if you haven't seen this. What's the natural, well, not the natural, what's the sort of progression here? If I think about, what I've done in terms of these ML5 videos. So I did intro to ML5, wherever that is, image classification and webcam. I at least can make a list of what are the things that I intend to do. So, Word to Vec, that's going to be in the fall. Now let's make a list here. I need to do the convolutional network. Just trying to think here. So I did image classification. You know what I think I might do? So I did this. I did plain image classification. I did image classification webcam. You do the feature extractor to make a classifier and do a regression. I think those are both kind of interesting. LSTM text, style transfer, pix to pix. These are all the things I could do. PoseNet, YOLO, and Word to Vec. So Word to Vec is going to come in the fall. So I'm going to do that in my A to Z course. Pix to pix and style transfer, I have some plans for those, but it's going to involve a guest. So that's also going to be fall. So these are the options right now if I was going to do more. LSTM is also, I'm planning to do that later, so I think I'll hold off on that because that's also for my fall class. So the feature extractor, PoseNet, and YOLO are the three things. YOLO is really slow right now, so I don't know to what extent. Let's run the example. It's worth doing that as a video. Oh, the camera is off. Person. That's pretty cool. Cell phone. Cell phone. Is there a bell in YOLO? Person. Come on, what about like a pencil? Cell phone. I really like to think there are cell phones and people. Okay. I think I'm too exhausted from the 4D to do anything else. I think I might. So all right, let's talk about time and schedule for a second. There's something like Tetris, straw poll. It sees a hand holding something and thinks it's a cell phone. That's super interesting. That's a very good point. So that's such a good point Alka makes in the chat in thinking about machine learning. All right, so I am going on vacation. I will be away at a secret location with very little internet for almost 3 weeks. There's other things going on during that time. My vacation isn't exactly 3 weeks, but I will be not live streaming next week, the week after, or the week after. Is today August? So this counts as a live stream, but 2 live streams in August. I will be back. Tetris is not happening right now. That's the lovely idea. 6:15. I mean, I need a fresh start. So I won't be back. So right now, the edited versions of these videos will come out slowly over the next few weeks. There's a good chance that I'm going to be able to come back and do just like one more. I want to try to produce a little bit more content for while I'm away tomorrow afternoon, Saturday. So I'm going to try to stop by because I'm going to be around here in the neighborhood, going from here to there, and I'm maybe to stop in for a couple hours. And I think it would actually, doing the feature extractor stuff, it's sort of a big topic, but it would be worth it. I'm just trying to decide, is that the next thing? Like, the machine learning stuff I got to like work up slowly. But I think actually the feature extractor is kind of the next thing. So the question is, the game of code writes in the chat, Tetris doesn't take long to make. It's pretty straightforward. So the question is, and I'm just sort of curious, I will do a straw poll, and I'm not going to do any of these topics right now, but I could do something a bit more substantial tomorrow. Whoa, is this the same thing I've always been using and they just like changed its design? Or this is what I've been using. Yes, this is what I've always been using. There's like strawpoll.me. Next topic. So this is hard because it's going to kind of need a runoff. Because really it's like, I want to say it's like ML5, allow multiple options. Oh, so you can vote for more than one thing. I might allow that. So you can kind of vote for like a couple more than one. ML5, feature extractor. So what the feature extractor is, it allows you to basically do what's called transfer learning. So take the MobileNet model and say like, hey, you don't know about what a pencil is? I'm going to show you a lot of pencils and add that as a label to something you can recognize. There's a bit more to it than that, obviously, in terms of the limitations of what you can do. ML5, PoseNet, and YOLO. Another option would be Tetris. Am I really putting that down there? And there was something else. Oh, the doodle classifier. And this is without ML5, with tf.js directly. That would be doing convolutional neural networks. And I kind of wanted to make a bunch of processing sketches that show how the pieces of a convolutional neural network work. So that would be part of that too. All right, so I think I just allowed people to check more than one, which is a little bit silly. But if you're like really interested in ML, so I don't know, you guys can try to game the system. But here is the URL for the straw poll. Right? I should have made you choose one. This multiple, I kind of wanted to make it that you could only pick two. But I guess, can you see the results if I don't show them? Like, I'm just going to go over here. View results. Yeah, anybody can see the results. Oh my God, Tetris. What size is this anything? Interesting. I'm going to vote for this. Hope you enjoy Tetris. I'm not saying I'm going to do what you vote for. I'm just curious to know. I don't know. I can't believe I put Tetris on there. What a mistake. Sudoku salt over. Okay. I mean, the link, someone can post it in the chat, but there it is. You should have put Voronoi. I know. I almost feel like Tetris I can handle more than Voronoi. People are interested in that doodle classifier. Interesting. It's pretty interesting results here. But is like Tetris just everybody's second choice? But really, if I only gave you one choice, you would all pick this one? That's what I was sort of planning to do. Well, how to code Tetris. Ooh. Code it yourself, Tetris programming from scratch. So I could just, 36 minutes, watch this. It's gonna take me 17 hours. Learn how to create a game Tetris in 6 minutes. And yet the video is 4 minutes, interesting. Method. So this is, I mean, Method's videos are excellent. I mean, I'm sure these videos are excellent too. I just haven't watched them, either these channels. Simple Tetris clone written in Java. Oh yeah, this is good. I'm gonna have to rotate stuff. Oh God. It's gonna be multi-part for sure, right? There's no way to not do it as a multi-part thing. Ooh. Tetris. Requirements. A left-right key, a hard drop key, a rotation key, a preview piece. Oh, I'm not doing the preview piece. Full set of all 7 kinds of shapes. I'm not doing the preview piece. That's definitely not happen. Is there like 1D Tetris instead of 2D that I could do? Here's a JavaScript. Under JavaScript, see Tetris JavaScript. Oh my God, this is like very little code. I could do this. Drawing some stuff. rotating some stuff. Oh God, this is going to be so painful. This is going to be so painful for me because I'm really going to do this without having done it in advance. So you're going to see a mess there of me. Let's refresh the results. Oh boy, not getting any better, is it? I might have to do the feature. I'm just warning you. Let's say it came down to there's ballot stuffing going on, isn't there? I think there's some ballot stuffing going on. All right, everybody. Thank you for tuning in. I could answer a few questions. Make the preview piece. No preview, no Tetris. Do Pong again. The preview part is easy? I guess so. If I make the drop, then if I make the drop button, the preview is just showing where the drop button's going to put it, right? So yeah, I can make the preview. All right, I'll make the preview. Just only use a few pieces like 2. Thank you. Tetris is so boring compared to the ML stuff. 4D Tetris. Well, I don't know what to do. I would say that people have spoken, but ultimately, I am the decider. That was a pretty... You need to use single transferable vote, really. What does that mean? 1D Tetris. Oh, there is a 1D Tetris. This is like, it needs to run Flash for, okay, allow. Oh yeah, this is 1D Tetris. This is awesome. This is really brilliant. Is this the same one? Yeah. 1D Tetris, everybody. Oh, camera went off. That's pretty brilliant. Would it be crazy to actually do 1D Tetris first? All right. So I definitely like the idea of doing Tetris with only a few different pieces. What if I did Tetris with just one tile pieces, and then I would incorporate tile? That might. Like I'm trying to think of the order to do this. Like what could I do in a single video? Tetris with all the pieces are just a single cell. And then as a part 2, I could add more complex pieces and rotation. Would that make sense? Oh, that's a good idea. Laos OS is saying, hey, I can work with you on 4D Tetris. Shouldn't I do 3D Tetris first? 1D Tetris on April Fools, that's a really good job. That's a really good idea. I'll try to remember that. Yeah, we could do a 4D Tetris. I would love to do a collaboration with Laos OS, so like some kind of like 4D Tetris thing would be really fun. So maybe we could think about doing, so 1D Tetris, then 2D, then 3D, yeah. I'm really exhausted. How many hours of live streaming have I done today? Like 4 hours. So I think I better go before I get talked into doing something else right again. I can't believe, what's nice is this hasn't crashed. I don't know why it was crashing so much earlier. Yeah, I have no idea either. All right, everybody. Let me go. I mean, no guarantees here, but I'm going to attempt to come back tomorrow. I probably should continue the machine learning stuff because That's kind of the track that I'm on. The Tesseract was a break from that. Now you're asking me to do Tetris. It's my fault for putting that in as the choices. I think I can't do Tetris tomorrow. I kind of feel like this desire to do one more little thing right now. It's a terrible idea. It's 6:30 feels early because I'm always running so late. Okay, this is probably never going to happen. Just in case you're wondering. What did I do? Assign. Shiftman. Oh, I did this. Barnsley Fern. I got to close some of these. I did this. This is sorted. I did this. I keep meaning to do this. Have I done this? That's a good winter-themed one. I really want to do tic-tac-toe and then that, what's that, min-max algorithm or something? Tic-tac-toe might be better than Tetris. Tic-tac-toe with neural network. Yeah, and I can have it play itself and learn. You are not a polling expert. The vote for the ML stuff got dived among multiple videos. Yeah, I agree. I agree. I'm reading about single transferable votes now. Snake. I have done the snake. Okay. Tic-tac-toe with min-max is pretty easy, but so satisfying and fun. .4D tic-tac-toe Tetris. Connect 4 with machine learning. That would be fun too. Connect 4. I like Connect 4. That's a fun game. Maybe I should just do 1D Tetris right now. If I do 1D Tetris right now, will you all be satisfied and I cannot do Tetris tomorrow? Is this okay? Options for the poll? All right, fine. I was going to make the only option yes. I'm voting for yes. All right. It's been decided. I could do 1D Tetris right now. I like that for April Fools, though. I could save it. I could do it now, but not release it until April Fools. Nobody has the URL. Nobody can see this URL. If you can catch it fast. Oh, it's here. Uh-oh. Uh-oh. Uh-huh. This is exciting. This is looking good. Connect 4 for your Italian followers. Uh-oh. Uh-oh. Things are going south fast. Oh boy. This is bad news, everybody. What if I read you some random numbers? If you do, well, I got to start with like 1D to get to 2D to get to 3D. Uh-oh. This is very confused. This is getting bad. Help me out, people. I kind of, ooh, all right. Okay. I'm just going to read a little of my book here. 53,717. I'm so tired. Somehow make my own voting system. Fractals are cool, but have nothing to do with Tetris. Rock, paper, scissors. Ooh, I love that. But the best rock, paper, scissors strategy is to be completely random, pure randomness. Boy, this is really, boy, this is like very polarizing. I'm just sitting here refreshing those. I'm sorry, I don't think I should do the 1D Tetris thing now. Fortunately, no seems to be the answer. Go home, it's dinner time. Vote no and receive. Okay, I think we're done with this poll. There's no consensus. There's no consensus here. There's no consensus. Oh, look at that. But I don't think I code this in this video. All right, everybody. Let's look at the Tesseract some more. It's interesting. It's nice to sort of hear what people are interested in, which is helpful to me. I am going to be going. How long has this live stream been going on? Over 2 hours, right? Yeah. Thank you for tuning in. Sorry that I just wasted like a half an hour of your time there. I'm going to look into some of these ideas and think about it. I might be back tomorrow. I can work that out. Otherwise, you won't actually see me in a live stream until the very end of the month, like August 28th or 27th or 29th. Is the 25th a Friday? Or 25th is a Saturday? 27th, whatever that Monday is, I think the 27th would be the earliest. Yeah. 2 hours and 30 minutes, yeah. So I set out what I meant to accomplish today, which was to program a Tesseract. I will take a few minutes to answer any questions. I will take a few minutes to answer any questions. One thing is that I'm working on captioning a lot of my videos. haven't been keeping up with that. If you are interested in submitting captions, I might as well mention, I mean, who's watching anymore now, but you can go to, there's a link that I can share. Let me share it in the chat. I'm really interested in getting English language and other languages as well, but often it's nice if a video doesn't have any English language captions to get that first because it makes translations easier. I'm just going to post a link in the chat to here is a place where you can, where's our live chat going on? Here's a place. Oh, Matt Graham, I just saw that question. This is a link. Did that just go in? Yes. That's a link where you can submit captions. So if anybody has time or interest in doing that, please do. Matt Graham asks, when do we receive the Slack invite via email? Well, guess what? You could receive it right now. I don't see you in here though. Oh, right. Okay, so Matt Graham, you need to go to the community. So I have a Slack channel which is for members and also patrons. If you want to join that, you can click the join button or click over to Patreon. You have to then go to the community tab. There's no Slack YouTube integration, so you have to go to the community tab, and then there's a post there with a link to a Google form, which you can enter in your email and your YouTube username so I can match it up, and then I will send you an invite. So if you do that in the next minute or two, I will do that. Thank you, Ryan. Nice comment to hear that you start computer science at university this September. That's wonderful. Good luck. Do I speak Spanish? I do not speak Spanish, no. iCubic asks, I'm going to take a class next week where I'll learn about AI and ML using the Python TensorFlow library. Do you have any tips for me? Have fun. Don't feel like you're the only one who doesn't understand stuff, because everybody else also doesn't understand stuff, but everybody's afraid to say it. And be critical and think about the data that's being used in a project and its applications. Those would be my pieces of advice. Can you talk a bit, Nabil asks, can you talk a bit about pix to pix? So if you're interested in pix to pix, I'll refer you to the work of Yining Shi and the ML5 library. I believe, I don't know if I'm going to be able to find this easily, but Yining Shi, pix to pix. I feel like hopefully she has a blog post about it. But anyway, I have a plan in the future to do, I thought there was a blog post maybe about her work with pix to pix and ML5, but I'm going to save that for another time. Are you more of a Java or a JavaScript kind of person? Java. Panman asks, what is feature extractor classifier? Oh, come on, I should do that tomorrow. That's gonna, trust me, the feature extractor stuff is so powerful and interesting. I should definitely do that tomorrow. Thank you for asking that. Totally makes sense. Well, what just happened here? It started over. That was about 37 seconds in. Second favorite programming language after Java and JavaScript. Wouldn't that be third favorite programming language? I don't have one. Is Udacity ML course good? I have no idea. Maybe. Will you ever do deep Q learning? Boy, I should really only pick out the questions that I'm equipped to answer. I don't know. Mr. Muse Addict, let me answer this question in the Slack channel directly, asking me about this project from a while ago. I will answer that. I'd rather not discuss that right now, though. Do you recommend to an engineer to use JavaScript for data science? Boy. So, as you might be aware if you've watched this channel before, I really try to stay away of recommending tools or particular programming languages. For me, The right programming language to use is the programming language that's in front of you right now. And everything has its pros and cons, and at some point you're going to find things that are like, oh gosh, this thing that I made in this programming language is kind of a disaster compared to how I'm doing it over here. But I don't think there's no easy answers to these questions. There's no, this is my project, use this. So I really can't answer that. Are you somebody who knows a little JavaScript and is interested in the field of data science? Tinkering around with TensorFlow.js, ML5, other JavaScript libraries, D3, looking at observable HQ notebooks. All of these things are possible and worth doing. Is JavaScript the language for data science? Probably not, but perfectly fine. Is it true that times 0.5 is faster than divided by 2? I hear that all the time. Madnik, stop ignoring me. I don't know what question I ignored, but if I either didn't see it or I ignored it for good reason. I'm trying to stick to on-topic questions and ones that I can answer. Is this stream starting in the middle or ending? It is ending. Looking at the chat, seeing more questions. Thanks everybody for your support. Just watching is a support, being a member is a support, recommending the videos to somebody is support, making your own stuff inspired by stuff that I made is support, deciding to not watch anymore because you have something else you want to do in your life is support. All those things are valid. All right. Did I go to college? Yes. Oh, the pencil eraser doesn't work. It's not capacitive. Somebody asked, what do I get if I would support you as a Patreon? So first of all, honestly, if you want to join as a member or as a patron, I would say do it because for some reason doing that makes you feel good and you have the means. Because what you get, I don't know. I don't know if I have anything really worthwhile for you. But I will say that the Slack channel is a wonderful community of pretty nice and welcoming people and a lot of experts in there, like way better answering questions than me. And I'm kind of not in there that often. I mean, I'm in there as much as I can. I like to be in there, but there's lots of people in there who are better equipped to answer your questions. So that's probably the main thing you get is kind of joining that particular subset of this community. And then, I will get around to mailing you stickers or a signed book and that kind of thing eventually. I just did a mailing today. It does take quite a while for me to do that. So again, if you want a book, I would suggest just buying it. But if you, so that's really why I really don't want to advocate too much for joining the Patreon or the YouTube membership. It certainly does help me have the resources and time to make these videos. But that's my answer. So I appreciate it, and I encourage you, if you feel like it's a thing you want to do, great. But I will love you just as much if you do not join. Wow, some really interesting questions here. What did you learn in college? Okay, 8 seconds left on the clock. I studied in college a long time ago. My major was mathematics and philosophy. I graduated in 1995, and I didn't do any computer programming at all in college, not once. I mean, maybe I did and I just don't remember, but if I did, it certainly wasn't substantive. And then I didn't actually do any computer, when graduating from college in 1995, I didn't do any programming. I think I took actually that's not true. I took an evening C++ course a year or two out of college just to see, and it didn't take. And then I started as an ITP student in 2001. So I think it was 27? And that's when I really started doing programming more seriously. I've never done it seriously, but I spent more time doing it. So I really started, to me, I was so young then, I feel like, but late in life comparatively, like, kids nowadays, my kids, my older son who is 10 probably did his first coding class in Scratch at the age of 7 maybe. He's done some P5 workshops since. Madnik45 asks, how old are you? And I say look only into your own username for my age. Okay. All right, so that's it, everybody. I'm going to go. I feel like I did not do what I wanted to do this week, which was generate tons of content to have new stuff on the channel over the next few weeks while I'm away. But I don't know why I'm worrying about this. Let the channel take a break. I will say that my commitment, hold on, just bear with me. I've been meaning to do this accounting. So if you don't mind, I want to do this accounting. I'm going to go to my channel because I want to figure out like what do I really need to make sure I do. I'm going to go to playlists. I'm going to go to created playlists. Oh, I just revealed something about myself. Does anybody watch this show? I only watched season one, but I love this show, The Genius. I really want to do coding challenges about The Genius. If anybody is a fan of The Genius, I don't know. It's amazing. I mean, I watched it a long time ago, and I meant to get to season 2, and I never just got around to it. Okay. I'm looking for created playlists. Yes, okay. This is why I don't like to be logged into my own account. Live streams. Live stream archive. There's 160. Jesus. Oh boy. Okay. So let's look. If somebody could do this full accounting for me, that would be, oh, it doesn't give me the dates here. Ugh, this is ridiculous. Okay, I don't think I can do this accounting right now. Because I just want to see the dates of each one of these here. So I could, I mentioned The Genius before, haven't I? I think I have, yeah. I really want to do an accounting of this. Now, so let's just see. Humor me for a second here. Let me just open this here. So working backwards, if I open all these in new tabs, I just want to go back to like June. I know that I was doing a ton in like April, May. So let's see. Does this at least have the date? Live streamed on May 11th. Okay. So let's go back to May. Which one was that? Because I might have been light in May due to thesis. Which one was that? That was 136. May the 4th, that's obviously May. And 134 is 134 is April. So let's close that out. So let's open up this. May, June, July, August. My goal is to average hey, new member, Priswall. Oh, did anybody, yes. Did anybody, I see Matt Graham. So when you fill out that, I need to match it with your username. I'm going to choose to trust this. So I'm going to send, yeah. By the way, I'm getting text messages from home because my Philips Hue lights, they flash when somebody joins. So hey, the lights are flashing. Okay, so I'm going to send those Slack invites soon. All right. Actually, what I should do is just work on my other stuff that I need to work on, just like keep live streaming. But I think it's Friday. I'm going to take a break. Okay, so wait. Oh, I'm getting so many messages. Okay, now let's look at this. Okay, so May 11th is 1. Whoops, what the? May 24th. Did I really not live stream between May 11th and May 24th? No, I messed up. I can't even do this right. Wait, there's no 137. What happened to live stream 137? Huh? Okay, hold on. Live stream 137, Shiftmen. Can anybody find live stream 137 faster than I can? Here it is. Promises in JavaScript. I'm going to edit this. I'm adding it to the playlist. Somehow it got left out. Add to playlist, live stream archive. Okay. Save changes. And now, if I go to that playlist, hit refresh. So now if I go to the bottom, it's totally going to be at the bottom, isn't it? Live stream 137. So can I move it up? Found it. Okay, promises there. Okay, so let's start over. Because these are at the beginning now. 136, 137. So 136, that's 137. 136 is May 11th. So that's number one. 137 is May 23rd. That's number one. 138 is May 24th. One. 139 is May 24th. I mean, I guess it's 2 in one day. I'm going to count that as 2 because these are long. This one's only an hour, 10 minutes. That might count as 1, but I don't know. 140 is May 31st. Whoops. I probably should delete one here. So that's a total of 4. 4.5. I'm going to say that's 4.5 in May. Okay. Now, 140. What did I stop at? 141 was May? Or is that June? No, June 8th. So 140 was May. I can't even keep track. My system is really flawed. May 31st. Okay, so 141 is June. Good, 2 hours and 15 minutes. 141. Where's 142? 142 is June. Good, 3 hours long. That's pretty good. 143, June. 2.5 hours long. June's got a lot, looks like. 144. So I'm only on June 18th. I've already got 4. Did I forget May 4th? I forgot May 4th. So 5.5. 145. 145 is June 27th. I took a little break there, it looks like, which is 145 is June 27th. 146 is July 20th. Oh, because I went away. Yeah, that makes sense. So June has 5. Okay, so 146 is July. And August, 1 July. 147 is also July 27th. 2 in July. Did I really only do 2 in July? I think there's a July 147. What's one? Is today 148? This was July? Yeah, last Friday. That makes sense. So did I forget May the 4th? Did I not get this one? 135. Yeah, somehow I missed 135, which was also in May. Okay, so May had 5.5. June had 5. July had 2. And August so far has, I'm going to count this as 2 because I did a full live stream this morning and this afternoon. So if we average that, 14.5 divided by 4. So I just need 1.5 more live streams, because if I get to 16 by the end of August, that's an average of 4. So I need 1.5 more. So if I do one tomorrow and I get one more in at the end of August, I'll actually be at 4 in August, and that will be good. So that's the sort of commitment I'm making in terms of people supporting through the membership and that sort of thing. Okay. All right, let me check these Slack invites. If you're in the chat right now and you just joined as a member, please let me know. Did I send the invites? Wait, hold on. I'm just gonna do a little double checking of this. I'm sending member Slack invites now. Where'd I go? Community. Community. Channel memberships. Okay, so now let me look for. Cool. 7 hours ago. Okay, great. This is validated. Slack invite coming in. Okay, now one more. One more coming. All right. Matt. Slack invite coming. And there we go. I'd be curious actually, yeah. So I'd be curious for a graph of actually the amount of time that I live streamed. I'm sure I could use the YouTube API or something. I really also, this is something I'm really like toying with. I sort of feel like the live Priswold, if you just joined, go to the community tab, find the members only post. There's click to the Google form and enter your email address there. And just put Priswall in the YouTube username column. I feel like the live streams and the edited videos should be separate channels. But I don't know how to break that apart now. It's like too late. How do I start a new channel from scratch and just say like, oh, if you want the live streams. So I think I'm probably not going to do that. But if someone wants to try to talk me into that, I'm open to the idea. Okay. I don't see any more, but anyway, I will look for those. Okay, I can't say goodbye. It's like a problem I have. So we'll see. I'm going to try to live stream for a little bit tomorrow. To be honest with you, I think I want to do some more ML5 stuff. Sorry to disappoint about the Tetris. I will keep that in mind. That's the thing about it though is like, when am I ever else going to do Tetris? I'm going to think about it. I'm going to sleep on it. I'm going to sleep on it. You can tweet me at Schiffman with your, strong-willed opinions, if you like. You can comment on any YouTube video you want. By the way, something weird happened the other day that I'm curious about. I wonder if I could pull this up. I think I can't pull this up without privacy issues. Let me see if I can. I'll just mention it. So I have this video, coding, visualizing 500K subscribers. This particular video, the other day, came up. Hey, look. This particular video, suddenly in my analytics was like 100 times the traffic that it would like normally have because it's an old video and nobody's watching it anymore. And then I went and looked at like geographically, and it was up everywhere, but the views from India were like way up compared to everything else. Did this get like linked from somewhere? Can anybody help me find that? If anybody has any idea why that happened, I'd be curious to recreate it. Let me just look at my analytics right now to make sure that's not continuing to happen. I guess it's just the arbitrariness of the YouTube recommendation algorithm. Is probably what it is. Right, the snake game is what, yes, because very few people 33 people in the last 60 minutes watched that video right now, which is not very much. I mean, it's amazing in many sense. Hold on, I'm gonna. Oh, interesting. Matthew in the chat makes a good suggestion. If you want to separate the live from the main channel, spend a year streaming to both a new live-only channel and the current Coding Train channel. I just feel like I wonder if there are people who want the notifications for the edited content and people who want the notifications for the live stream. And those are two, and having all that together redundantly in the same channel is like too much. And maybe I should have just a coding train live and coding train channel. I don't know the answer to that. So I'm curious for your views. I gotta go. I just can't say goodbye. Thank you for tuning in and entering the fourth dimension with me today. I enjoyed it. I'm so pleased. This is something I've looked at for years and thought, I have no idea how to do that. I don't understand anything about it. So, what do I do when I finish the form? Priswall. Priswall. Just wait, Priswall. Here comes. Here comes Priswall. Invitation sent. All right. So because I'm going to be away for so long, this does help me kind of think like, I actually don't need to do the live stream tomorrow just in terms of my own personal accounting to feel like I'm doing the amount that I sort of set out to do with my goals. But it would be nice to get a little bit further with some stuff before tomorrow. Don't get your hopes up in terms of the Tetris thing. That honestly seems pretty unlikely. But thank you for indulging me with the straw poll. I do see it as something people are interested in. And I will see you all tomorrow. Okay. Goodbye, everybody. See you maybe tomorrow, if not at the end of the month. Stay tuned for the edited versions of the videos. And as always, thank you for your support. I need a tagline. Like Jabril has that great, like, always remember to always feed your curiosity. I don't have a good tagline. This is all I got is this. It's been a while. I'm going to play you out with the trailer. Bye, everybody. And that totally did not work. Whoops. How come the trailer's not playing? Oh, wait. That's weird. How come the trailer's not playing? Loop, restart, hide source. Huh. Well, I guess you won't be seeing the trailer. That's weird. Let me hold on. Let me just bear with me for a second. Let me add a new scene here. Trailer 2. And then all I need to do is add a media source, right? Media source? No, not a media source. A VLC, video source, video capture device, scene, media source, I thought. How do I add a video to Open Broadcast Studio? I know you can't see me. You've entered the fifth dimension. Browser source? No, media source. Local file, browse. Give me that file. Oh, I deleted that file, I bet. Oh, I deleted it. Because I was doing like a clean out of the, hold on. I was doing a clean out of the, I can't like examine this layer without, oops, not filters. I was doing a clean out of, Google, yeah, hold on. Let's see if it's somebody. Because I got rid of Google Drive on this computer. Let's see if it's somewhere else. Okay, hold on. I said I was gonna play out with the trailer. I'm gonna revive. I gotta make some icons. Come on, people. Make me some icons. Actually, you know what? I have to email. I'm gonna take care of that. I got an idea. Oops. Just give me a second. This isn't gonna take too long. We're gonna get that trailer. I'm gonna download it. deleted it off the computer. Trailer. Okay. Okay, download. Download anyway. Download anyway. Is it downloaded? It is downloaded. The trailer is coming back. Properties, browse. Where is it? In downloads? There it is. Just leave it in downloads. That's a good place for it. Oh, there you go. See you all maybe tomorrow.
Some crazy idea. We'll figure out what
Sorry about this Sudoku solver suggestions. I'm ignoring them on purpose because I'm afraid of doing that. I had to mute my microphone.